All right, so we've done a lot of data transformation and manipulation, but we really haven't gotten into any kind of data visualization. And a key part of generating insights from our data is being able to visualize. Now, there's several different types of visualization capabilities within R. We have base R plotting capabilities, and then we have a whole bunch of other packages. But the most popular visualization library within R is ggplot2. And so that is what we are going to learn about here. All right, so within the data pipeline, we can see we have now figured out how to import data. We figured out how to tidy up data if we need to. We know how to do different kinds of transformations, whether that is filtering, selecting, arranging our data, creating new variables. How can we actually parse out whether it's parts of strings, parts of dates, adding new variables and everything. And now we're ready to do some visualization. All right, so like I said, R has a lot of different systems for making plots and graphs. ggplot2 is one, the most popular, likely because it is the most elegant and the most versatile. And two, ggplot implements what we call the grammar of graphics theory. There's actually a book out there by Leland Wilkinson that's a great read if you have time. And it focuses on this idea of the grammar of graphics when we do visualization. And ggplot2 is built on that theory. All right, so real high level, the way that ggplot works is to think about building a plot in layers, right? We take our data, we identify the different types of variables that we want to plot or to show up on our plot, and then we can define what geometric shapes we want to plot this with. We can manipulate our scales. We can do faceting, which we'll talk about what that means in a little bit, and we can add new titles, or let's say not just overall title for a plot, but we could add subtitles. We could add new titles for our X and Y axes and the like, right? So think of this as we build a plot in different layers. And the nice thing is this allows us to create some very nice plots that are both publication worthy, but then also provides a lot of good insight into patterns that exist within our data. All right, so to follow along, we're going to go ahead, we're going to load ggplot2 for plotting. We're going to do a lot of data transformation along the way, so we're going to be using dplyr. Now, most of the slides that you see in the examples we do, we're going to use this MPG. This is a built-in data set, or not a built-in, but it's a data set that comes with ggplot. So it's built into ggplot, but not base R. Now, for the exercise data, the your turn exercises, we're going to use the complete journey, and we're going to use the transactions data and the products data. All right, so at a very fundamental level, we should be thinking about a plot just being an empty canvas, just a blank image that we want to start adding layers to, right? So the way to create that canvas is to call this ggplot, and then we map our data to the plot. This does not show anything. In fact, if I run this on my end, what we end up seeing is down in our plots window, right? We just have this blank canvas that pops up. It's basically R saying, hey, look, we're ready to add layers to this empty plot. So the next step is we want to map variables to parts of our plot, okay? And we do that with a function that's called AES. This stands for aesthetics. We want to add aesthetics to our plot. And so we can map onto the x-axis a variable of interest. In this case, we have this displacement variable. And then on the y-axis, we're mapping this HWY. This is highway miles per gallon, right? So here, all we're doing is we're mapping variables to our x and y axes. And we can see that on the x and y, the range of values that exist in those variables start showing up on the axis. We haven't actually plotted any data yet, but we have at least made a connection from our axes to the variables of interest. All right, so the next step, we want to actually have our data show up. We want to use certain types of shapes, geometric shapes, in order to plot our data. And so within ggplot, we do that with various geom underscore and then whatever the shape is that we want to use to plot. And there are well over 30 built-in geoms, and then there's other packages that provide even more geoms, right? And so we'll illustrate many of these along the way. So for example, say we want to plot the distribution of the highway variable, which we see over here, right? So what we can do is we can say, hey, I want to first, let's create this canvas where we have our x-axis is mapped to our highways variable and we're ready to plot. So I can add a layer where I add a histogram, and that's going to look like these bar charts here. This is just a histogram showing the distribution of the different highway miles per gallon numbers and the number of instances that occur within this data set. Or we could illustrate this with this geom frequency polygram. And so that is very similar to this histogram, except that's this middle one here. It just shows kind of an outline of our histogram. Or we could also use a geom density to do a density plot, right? And again, we see a very similar plot to these other two, and it's just showing the distribution. So these are just three different geoms that we can use to plot the distribution of a single univariate variable. Now, if we want to look at some at a plot that combines both an x and a y-axis, or we want to compare basically bivariate distributions, we could do so. So in this first plot, we are going to look at displacement on the x-axis and highway miles per gallon on the y-axis. Now we can create a scatter plot by adding the geom point, and that's this one on the left. Okay, so geom point is basically what we use to create a normal scatter plot. So now we have displacement and highway miles per gallon, and the points illustrate each observation. Now I could also do a box plot. So here I'm going to map the class, right? So here, let me do this in R so we can see a little bit more clearly. And what we see is the class variable, which we see right here, has different types of vehicles. So we have two-seaters, compact cars, mid-size vehicles, minivans, pickups, and the like. And so what we're doing here is, for each one of these classes, we have a box plot that plots the distribution of the highway miles per gallon. And a very similar one to that is, instead of geom box plot, if I change this to be a geom violin, we get a violin plot, right? And this just kind of shows, or is another way to kind of illustrate the distribution of values that exists for that combination of the class, vehicle class, and that vehicle's highway miles per gallon. Now, the thing to kind of point out is certain geoms are kind of built for like univariate analysis, such as like histograms. Histograms are meant to show the distribution of a single variable. So when we do that, we only need to map one of our variables to our plot. Now, some of these geoms require both an x and a y variable to be mapped, such as geom point, right? You can't do a scatter plot with just a single variable, right? So in those cases, we have to map an x and a y. Now, if you don't, let's say you use a bivariate geom, but only supply one variable, right? We get an error, right? And it says geom point requires the following missing aesthetic, right? So if you make a mistake and you use the wrong geom for the type of plot that you're trying to create, whether it's univariate or bivariate, R is going to tell you. All right, so what I want you to do, I want you to go ahead and pause the video, and I want you to use transactions and products data to create these three different plots. One is a chart that illustrates the distribution of sales value. Another one to create a chart that shows the counts for each brand, and then create a scatter plot of quantity versus sales value. All right, so to get these, the first one is basically we want to do a histogram to show the distribution of our sales value variable. And we can do that here by using Geom histogram. Now note, here I get a little message and it says stat bin using bins equals 30. Pick better value with bin width. So by default, Geom histogram will apply 30 bins. We could adjust this and we could say, hey, look, I want 50 bins. And that's going to just create a finer, detailed histogram. Now for number 2, create a chart that shows the counts for each brand. We can do that with the bar chart. So now we map the x-axis to the brand. And there's 2 brands in our products data, either national or private. And Geom bar is going to give you a bar chart that shows the number of instances or counts for that particular level or brand. And the last one was create a scatter plot of quantity versus sales value. So scatter plot, that should signal that we want to use Geom point, and we map quantity to our x-axis, sales value to our y-axis, and we get this scatter plot. Now it takes a little bit of time, and the main reason for that is because we have a lot of observations, and so ggplot is actually plotting every single observation in the data set. All right, so let's talk about how we can change certain visual aesthetics within our plots. And there's 2 different ways we can do this. We can do it with non-mapping aesthetics, and then we can also do mapping aesthetics. And we can use both of these to change maybe the color, the size, the shape of our points, or geometric shapes to represent data, either manually specifying to, like, let's say red or blue, or based off of other variables. So for example, say we have scatter plot, Geom point. So let me go ahead and run the default and we can see what this looks like in R. So we can see that the default scatter plot looks like this, but I may want to change it to be blue, right? And so I can do that by passing color equals blue within the Geom. Okay, and I may want to change the actual shape. So let's make the shape be equal to 17. Now, the way that R does shapes is you don't specify like triangle in this case. That's actually what 17 is. You can look at this question mark PCH, and what this will provide is, if I go down here, here we go. We have a mapping of the different shapes that we can use to represent our points, and here we use 17, right? So all these different shapes. I can also change the size. We see here, size equals 2, and I could change alpha equals 0.5. Now, an interesting thing here is when I do this, so let me go ahead and I'm gonna run all this within R, and you're gonna see that we have some where we have darker points and some that are lighter points. And the reason for this is because we actually have data points that are laying right on top of each other. And since we changed the alpha, this is the opacity of our points, right? Although we have partially transparent points, when you stack them on top of each other, that's making them darker, right? So these darker points just illustrate points where we have more than one observation there, right? We could actually apply this new geom that's called geom jitter. And geom jitter is basically taking a scatter plot, but it adds a little bit of, like, a very small amount of random noise to move the points away. And that can allow us to kind of move overlapping points away from one another if we run into that problem. Now, within geom jitter, there are arguments that you can use that specify like how much spread that we want to have. All right, so as we see on the left here, we can change aesthetics by basically within the geom specifying exactly which aesthetic we want to change and to what value. So we could say we want to change the color to be blue. Now what we can also do is we could map an aesthetic to a variable, right? So here, instead of calling color equals blue within Geom, what I could do is I could call color within the AES function and then specify a variable that we want to map to that, right? And when we do that, now what happens is we get a legend here that shows up, and data points that are associated with each level within this variable will get a unique color, right? So this is a way that we can map additional variables to different aesthetics within our plot, right? The key thing to remember here is if you want to change, color or size manually to a specified value, we do that within the geom itself. If we want to map another variable to an aesthetic, we always do that within the AES function call. All right, so go ahead, put this to test, pause the video, and I want you to create a scatter plot of quantity versus sales value and color all the points blue. Then I want you to create a scatter plot of quantity versus sales value and color all points based on brand, which is a variable that is in the products. So to do this, you're going to have to join the transactions in the products data. All right, so to accomplish this, the first one, we're going to do a scatter plot of quantity. So we map quantity to the x-axis and sales value to the y-axis. And then we can go ahead, use geom point to create the scatter plot, but we want to change the color of the points to blue. Now, alternatively, what we could do is we could join our transactions with our products. And then what we could do is we can map the color aesthetic to the brand variable, and we do that within the AES function call. And then when we call geom point, we get a scatter plot. We can see we have a lot of points that are colored this. I'm colorblind, so I think it's like a green gray or something like that, or bluish green gray something. That maps to the private brand, and all the red here is mapped to the national brand. All right, we're going to talk about a thing that's called small multiples. And this came into popularity a little while back, and it was because of Edward Tufte. If you've heard of Edward Tufte, let me grab a book. Right, Beautiful Evidence. He's got a bunch of books, actually fantastic. He does a lot of focusing on how do we represent and visualize data. But Edward Tufte came up with the idea of these small multiples. And we can create these within R. And we can use basically one of two facet underscore functions to create small multiples. So the first one is if we only want to create small multiple plots of something, let's say a scatter plot, but we want to have an individual scatter plot for each level of another variable, we can use facet wrap, right? So let's go ahead and look at, I'm just going to create the basic code here for a scatter plot of displacement versus highway. And we get this. Now I could color the points by the, based off of the class of the vehicle, or another alternative is to have an individual scatter plot for each level, right? So rather than coloring, I'm actually splitting up the plots, and now I have a scatter plot for each of the different levels or classes of vehicles, for two-seater, for compact, midsize, right? And so this really helps to kind of isolate the patterns that exist within each level of another variable, okay? Now, if you want to actually create a grid of small multiples based off of two other variables, so for example, say we want to have a scatter plot for each drivetrain and cylinder, right? Now we would use facet grid, and in facet grid we can specify the two different variables, and we use this variable 1 tilde and then the variable 2, right? And when we run that, what we see is we have the drivetrain along the rows, right? So we have four-wheel, front wheel, and rear wheel drive. And then we have cylinders are represented in the columns. Apparently there's a 5-cylinder vehicle. Actually, there's 2 of them. 6-cylinder and 8-cylinder, okay? So using these different facet underscore functions, what we can now do is take a certain scatter plot or histogram or something like that, but get an individual plot for each level of another variable or possibly two other variables. So I want you to kind of put this to test. And what I want you to do is identify, is there a difference in the relationship between quantity and sales value based off of the day of the week? All right, so to answer this, we actually have to do several things. One, we need to extract the day of the week from transaction timestamp. So this is going to force you to think about when we were dealing with date timestamps, how do we extract something such as the day of week? Then I want you to create a scatter plot of quantity versus sales value, and then you'll need to facet by the day of week, right? So there's 3 steps here. See if you can take a crack at this one. All right, so what this would look like is the first step is to take our transactions data, and we want to extract the day of the week, right? So to do this, I'm going to use mutate. I'm going to create a new variable called day, and I'm going to use the lubridate package, and I'm going to use the wday, the weekday function, and I'm going to extract that weekday from the transaction timestamp. Okay, and I use label equals true, so rather than just getting the number of the day, I actually get, is it Sunday, Monday, Tuesday, and so on. And then I'm going to go ahead, I'm going to plot or pipe that right into ggplot, and I'm going to create a scatter plot here of quantity versus sales value. I use geom point to create my scatter plot. But what I want to do is I want to separate and get a small scatter plot or small multiple plot for each day of the week. So of each day. So this is a variable I just created up here in mutate. And you can see the output that we get. So now what we could do, here we see that for the most part, we have a similar pattern for each day of the week. But if we had large changes or large differences, we would be able to identify the different patterns that exist given the day of the week. Okay, so now let's move on to titles and axes. So lots of times we want to add some more context around our plot, and we may do this with different titles or adjusting the axes, maybe a different title on the axis or the tick marks. And so we can do this a few different ways. So first of all, we can add titles with ggtitle or also with the labs function. These are very similar functions that we can do. ggtitle will allow us to add a main title along with a subtitle. The labs function actually allows us to add a main title, a subtitle, but then also a caption. So here we add basically where the data came from, this fueleconomy.gov website, and you can see down here at the bottom of this plot, it's added that caption. Now we can also adjust the axes in our plots using various scale underscore functions. Right? So say we wanted to plot, here's a new data set that just plots Texas housing. And if I just plot this by default, what happens is I get this plot that's kind of tough to read because everything's really bunched up down here at 0. So what we could do is we could add this scale underscore x underscore log 10. What this means is I want to adjust my x-axis, right? Scale x, the scale of my x-axis to be logarithmic. Now when I do that, you can see it actually stretches out this x-axis, puts it on a log scale, and we can now see a more definitive pattern that exists. However, a problem still exists in that we have the scientific notation for these tick marks. And that's always, you're always sitting there thinking like, okay, exactly 1e to the 7th, what was that again? Well, to make it easier and better formatted, we can add some more arguments within our scale x and scale y parameters. Well, one, we can adjust the name of our plot, right? We just say, hey, I want to rename my axis to be median sales price. And then there is this labels argument. And we can use, so this is actually a scales package that comes when we install ggplot. And within there is this there's various functions. One is dollar, one is comma, and there's many other ones. And this allows us to actually format our plot so that the x-axis tick marks are on, like here's a comma formatted. So let's look at scale X, right? We said make the labels be comma formatted. We see that we have that down here, which is way easier to read than what we had over here in scientific notation. And we can even take our y-axis, which was the median sales price, right? So that's a dollar value, and we can actually reformat the tick marks to be dollar formatted. Now this is a much better plot, easier to read, and it's more nicely formatted. Right, so we can put this all together. We can add titles, subtitles, a caption, and we can reformat our y and x-axis, and that starts to create these very nicely formatted plots. Right, so when you're doing a report, hint hint, when you're doing your projects within this class, I would expect your plots to be highly formatted. Same thing with when you move on to work and do stuff for your whatever organization you're going to work at. When you do a report for your boss or other stakeholders, you're going to want to create plots that are highly tuned and refined and nicely formatted. All right, so go ahead. I want you to take this challenge, stop the video, and complete this code. And the objective here is to plot the relationship between total basket sales and quantity. See if you can adjust the X and Y axis titles, and also can you add a main title. All right, so here is one approach to do. You can see that I added basically, if we were to just run this code, we can see the not very well formatted plot, which will come here, right? So we definitely see a pattern here, but we got everything bunch of points bunched down by 0. So by doing an X and a Y logarithmic, we kind of stretch out those axes at the lower end, and we can start to see new patterns that come out, right? You can also see I changed the names of the X and the Y axis. I added a overall title for the plot, and then I reformatted the Y axis to be in dollars, right? And you could do the same thing for the X axis if you want to reformat that to be comma separated, because we do get into the 1,000 and 10,000 units down here. All right, so one last thing to kind of discuss is the idea of overplotting. So overplotting is super useful when we can, it allows us to add additional geoms that can highlight certain patterns in our plots. So what this can look like is, say we do just a typical scatter plot. And so here we can see we have this. Now we can see that there's definitely a pattern here, right? We've got this increasing pattern where it looks like as volume increases, the median sales price, which is what this Texas housing data is, tends to go up, right? But if we want to emphasize that, right, we could go ahead and we can add an additional geom at the end. And what this geom smooth is going to do, it's going to add a smoothing line, basically, where it's going to show what is the pattern, the generalized pattern. And so the actual smoother here isn't very important for you to understand, but it's called the Loess smoother. And it kind of plots a nonlinear line that kind of shows and represents the overall pattern in this data. Now, we could say, hey, I want you to plot a linear line, right? And this gets into linear regression, which we will see later on in this course. But this will force that line to be straight. So if we were to try to force this data into a linear regression model, this is actually what that model would fit. Right? So now we can start combining a lot of these different things to kind of highlight different types of patterns. For example, here, these lines of code right here will actually create a linear line for the median sale price versus the volume of homes sold for each month, right? So now we could see, in this case, it all looks pretty similar. What we could actually do is, instead of forcing it to be linear, we could say, give me a smoother to see if there's any finer, non-linear differences in the trends. And we do see that we have some differences here if we kind of compare. But for the most part, overall, they're pretty similar. But doing this right here is something that would allow us to see if there's a strong deviation in a pattern for a given month. We would likely see that come up by doing this overplotting procedure here. Now, one thing to kind of call out is when we do overplotting, again, we can do it at either the global level or what we would call the local, right? So for example, the global level, here's some data. What we do is we're going to take that MPG data and we are going to map displacement to the x-axis, highway miles per gallon to the y-axis, and then we want to color based off a drivetrain. And when we do that within this global AES function call, now every geom that we follow that with, here we have geom point and geom smooth, is going to apply a different color to that geometric shape based off the drivetrain. So we can see that both the points and the lines here are colored based off of the drivetrain. Now, if we wanted to, let's say, have all the colors be on the scatter plot be black, but we only want to map the drivetrain variable to the smoother here, then we could follow up with another AES function call within that geom specifically. And so then that way, whatever aesthetic mapping we specify in that geom, it does not get shared by the other geometric shapes. So it all depends on what you're trying to do with your plot. All right, so is that all? Not at all, not even remotely close. There are so many great things that ggplot can do, so many great extensions. For example, we can do mapping. We can even do, mapping is provided by a ggmap package. Plotly allows us to have interactive type of plots, and we can even zoom in. We can have animated plots where they build over time to kind of emphasize maybe certain patterns or differences. And there's many more, right? If you go to this website here, this has all kinds of extensions that are developed and built for ggplot. And there's so many different things that you can do. And you can just kind of go here and take a look at all the different options within the gallery. And it's amazing what kind of plots you can create. All right, so main things to remember here, ggplot, that function is going to create the base canvas for our overall plot. We use the AES function or the aesthetic function to map variables to different plot aesthetics such as the X and Y axis or maybe to different shapes within our plots. We use the various geom underscore functions so that we can display the data with different geometric shapes. And then we can use facet underscore, either facet wrap or facet grid to create small multiples. And then there's various other functions that we can use to adjust titles, like create and adjust titles, and even adjust the axes, reformat the axes within our plot. Definitely check out this website for the ggplot2 package. A great resource, lots of good information. There's also a cheat sheet that allows you to kind of have a quick reference resource to use. That's really good, and you can find that under the cheat sheets within R. And with that, I would say go into the lessons, dig into the reading lessons, goes into more detail on some of these, gets you writing a lot more with the actual code. And if you still have questions after that, hit up the discussion board on Canvas.